Good evening guys to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So guys, this is a mock test for HPCL. As you know, now only 1 month is there for this examination, that is HPCL. So guys, today we have a mock test for the same. Okay, so in the mock test we are following the same pattern as you know for HPCL it is, and here we are going to cover 85 technical questions, as we are going to cover technical part today, and for non-tech part you know we have different time for that. Okay, so 85 questions we will be covering and all the subjects would be covered. It is a mock test guys, so just like the session, share the session and subscribe the channel so that other student can also reach here. So we are starting guys, and I will be taking care of the subjects like strength of material, theory of machines, vibration, engineering mechanics, production. Okay, so these topic I will be taking care of. Okay, and rest topic then Chandra sir and Vipin sir would be joining for the other topics. Yes, Pudina Yadav, good afternoon dear. So here we are going to start. Before that, this is some introduction about me. I'm having around 10 plus years of experience and written many research and review papers. These are my areas of expertise. And yes, I would like to add one more subject here. Yes, machine design is also covered in my part only. So after me, then Chandra sir and Vipin sir will also join for the upcoming topics. So guys, this is related to one information, that is last 121 day strategy for GATE 2023. On 4th of October at 8 PM, Joshi sir would be taking this session. You can register for this workshop if you want. Tomato Singh, good afternoon dear. So guys, to download free ebook for the GATE preparation and also to register for the workshop, you can see the link is present in the description box. This is the very first question guys in front of you. This question is from strength of material. Okay, this question is from strength of material. So guys, just like and share the session so that other student can also join it. Yes, just solve it guys, solve it. Yes, let me share the link to the student so that other student can also join it fast. Yes. So what would be the answer guys? Please tell me that. What would be the answer? What would be the answer guys? Please tell me that. Yes. Very good. Tomato Singh is saying the answer is C. What about others? Yes, Pudina. What will be the answer? The strain energy stored in a body due to the external load is known as. Is it proof resilience? It is resilience. It is resonance or modulus of resilience. So my dear, this is the question. So guys, it is not mentioned in the question that within the elastic limit or not. So we will be answering it arbitrarily, and the answer for this is going to be resilience, because you know that whenever we are looking at up to elastic limit or not, toughness is not in the option. So automatically it would be up to elastic limit only, and the answer will be resilience, because proof resilience is the maximum value of resilience. If their maximum word would be there, then the answer will become proof resilience. Resonance cannot be the answer. And if the strain energy they are asking, if it would be strain energy per unit volume, then it would be modulus of resilience. So as it is only strain energy, the answer is going to be C. Very good, Mani. The answer is correct. Nora, very good. The answer is correct. Question number 2. This is from computer integrated manufacturing. This is from production guys. Yes. So guys, quickly share the session into the group so that other student can also join it. The mirror image for a 2D reflection which is generated related to an axis of reflection by rotating the object by. Yes guys, the mirror image for a 2D reflection is generated relative to an axis of reflection by rotating it. So by which angle you need to rotate it? Yes, Nora is saying the answer to be B, Podina is saying B, Tomato is saying B, Mani is also saying B. So guys, let us say we have the axis like this. We have the axis like this, and this is a point. Okay, so if you want to make the mirror image of this point about y-axis, so let us say this is going to be the mirror image. So if I rotate this point by some angle, and this point will become its image, so that angle would be what? This angle will be 180 degree. After 180 degree rotation, it will reach here, and 360 it will reach again here. So my dear, the answer will be B for this. And guys, these are the level of questions of HPCL only. Okay. Yes, the answer is B for the same. Question number 3, guys. This is related to theory of machines and from cams and follower. I already told you we are going to cover each and everything for this topic. For the topics, every topic is covered in this test. Okay, the level is very much similar to the HPCL exam level. The smallest circle that can be drawn from the center of the cam and tangent to the pitch curve of a cam with the roller follower is, yes, what would be the answer, guys? So if we have this to be a cam, okay, if we have this to be a cam, this to be a roller follower, okay, you know that. So my dear, if we have some cam center here, if we are going to start a circle from this cam center, and that circle should be tangent to the pitch curve. You know, pitch curve is going to be like this. This is going to be pitch curve. So my dear, the circle which is going to be tangent to the pitch curve, you know, there will be one circle which is tangent to the cam profile as well. So the circle which is tangent to cam profile is said to be the base circle, and this circle is said to be the prime circle. So what would be the answer, guys? All of you are saying B, all of you are aligned at B, and guys, yes, you are correct. The answer for this will be B, which is nothing but the prime circle. It is correct. Moving to the next question, guys. This is from engineering mechanics. So you can see every question is from different subjects, from different topic. So everything is clear, everything is covered, guys. Yes. Tomato is saying the answer to be 0. Very good, guys. So just like and share the session, guys. I'm also sharing it in the groups. Yes. Give me the answer, guys. Fine. लेवल इंक्रीज करो. टमाटर सिंह, दिस इज HPCL पेपर. HPCL इसमें अगर आप देखेंगे तो कुछ क्वेश्चन प्रीवियस ईयर्स HPCL पेपर के हैं, तो लेवल इंक्रीज होगा, जो लेवल ऑफ एग्जाम होगा वही तो लेंगे. दिस इज फॉर HPCL, सो दिस इज द लेवल ऑफ HPCL. इफ यू सी BHEL लास्ट वीक वी हैव टेकन, see the level of that questions. Okay, so this is related to HPCL, so level we are taking up to the HPCL only. So guys, when you see the coefficient of restitution, it is going to be 1 for perfectly elastic collision. Okay, for perfectly elastic collision, and it is going to be 0 for perfectly inelastic collision. Perfectly inelastic collision. So guys, the answer is going to be 0. B is the right answer for this one. Okay, so let us see the next question, guys. Next question is related to the heat treatment, that is material size. This is related to the heat treatment, that is material size. So guys, just try to solve this one. The hardness of the steel can be reduced considerably by the treatment of normalizing, hardening, normalizing, annealing and hardening. Yes. Tomato, what will be the answer? So guys, this is the HPCL level. As I already said, based on exam we are taking. So if you see the GATE champion series, that is going for the GATE level. So based on the level of exam, the level of questions are decided. Yes, they are asking about the hardness of the steel can be reduced. Look this word, Pudina, hardness is getting reduced. C पर जाएंगे. Yes. So my dear, you know, hardening is done to increase the hardness. Okay. Then if you see the normalizing and hardening, this is once again cannot be the answer because hardening is there. Normalizing, when we are talking about, my dear, if we compare normalizing and annealing, obviously annealing will reduce the hardness, because in annealing we are going for majorly stress relief phenomena, and that is why the answer for this is going to be C only, because in normalizing also we get fine grain structures, so there also the strength and hardness are better than the coarse grain structure. Yes, very good. Priyanka, hello dear. So this is the sixth question, and this is once again from engineering mechanics. Yes. So guys, as you know, calculator is not allowed in this paper. Okay, so we have taken the level similar to HPCL. Even I will say 10 to 15 question I have taken from the previous year's paper, so that you can match that level is same. Okay. So dear, a wheel accelerate uniformly from a velocity of 10 radian per second. So omega initial is given as 10 radians per second. And you can see the omega final is given as 60 radians per second. And they are saying the time for the change is 20 seconds. You need to find out the angular acceleration, guys. So just find out the angular acceleration for the same. So you know the equation in the linear motion as v is equals to u plus at. Here the equation will be omega final is equals to omega initial plus alpha times of t. So guys, just find out the value of alpha. Okay, you have all the values. Yes, Priyanka, what would be the answer? Tomato is saying D, Podina is saying D. Nora, what would be the answer? So the answer will be D. So you can put the value. It is 60 is equals to 10 plus alpha times of 20. So alpha will be coming out to be 2.5 radian per second ka square. D is the right answer, guys. D is the right answer. Now question number 7, guys. The fundamental property of material able to resist the abrasion. Able to resist the abrasion. The options are resilience, toughness, malleability and hardness. This can be considered from SOM or material science, because in both the topics properties of materials are there. Tomato Singh is saying the answer to be D. Podina is saying the answer to be D. Very good. Yes, Priyanka, Mani, Nora, what would be the answer for this one? Yes, yes, yes. So guys, the answer is going to be hardness. So my dear, hardness is the property which resists any kind of indentation, which resists any kind of scratches, which resists any kind of abrasion. So guys, yes, for all these only hardness is the property. Question number 8, guys. This is related to once again the strength of material. You have a simply supported beam of length 4 meter. Okay, they have given the length of 4 meter and they have given the value of I and also given the value of load as 9 kilonewton. And they are talking about the deflection of the beam. Okay, the deflection of the beam. Obviously, if nothing is mentioned, we will talk about the maximum deflection. So you know the formula for this is PL cube upon 48 EI. So you just need to put the value and get the answer, guys. Solve it and give the answer. Formula I have written. Priyanka is saying answer is B. Okay, what about others? What about others? Yes. Formula is there in front of you, guys. You just need to put the value and get the answer. Yes. Load is 9 kilonewton. Length is 4 meter. 48. Young's modulus is 200 GPa. I is 12 into 10 to the power 6 mm4. Now everything is in mm, so the answer will also be coming in mm. Solve it and get the answer. Yes, guys. And do like and share the session so that others can also join it. What will be the answer, guys? Yes. Solve it and give the answer, guys. Solve it and give the answer. Okay, Podina is saying C, Tomato is saying C. So the answer for this will be C. Yes, when you will see all the things are getting cancelled out and you will be getting the answer to be 5 mm. Okay, the answer will be coming out to be 5 mm for this. C is the right answer, guys. Yes, moving to the next question. Next question is related to the elastic constants and their relation. The topic is from strength of material. Yes. Very good, Priyanka, Pudina, Tomato, Money, where are you, bhai? Solve this question, guys, now. The relationship between Young's modulus and modulus of rigidity. This is a previous year's question of HPCL as well. Kameshwari is saying A, Pudina is saying D, Tomato is saying D. Okay, Priyanka, what about you? You know E is equals to 2G into 1 plus mu. Okay, E is equals to 3K into 1 minus 2 mu. So if you see this relation, we can write G is equals to E by 2 into 1 plus mu. So the answer for this is D. Very good, guys. Moving to next question. Once again from material science, heat treatment of steels. Yes, nitriding process, the gas used is oxygen, hydrogen, carbon oxide or ammonia. Yes, Tomato, this is the level of HPCL. HPCL is going to be easier, BHEL is going to be difficult. That is for sure. Okay. So if you see previous year's question, you will say that they are exactly matching the level. What about this question? Yes. Okay, Tomato is skipping this. Pudina, Kameshwari, Priyanka. What about you guys? Yes, yes, yes. Please tell me that. Priyanka, Kameshwari. Okay, skip. So I am telling you guys, for nitriding process, we are going to add nitrogen. We are going to add nitrogen to surface. Can you tell me out of these all which element is which gas is having nitrogen? Which gas is having nitrogen out of these? Yes. Which gas out of this is having the nitrogen? Arey bhai, this is oxygen, this is hydrogen, this is carbon dioxide. Ammonia is NH3. So when you will use ammonia, then only nitrogen will be coming to the surface. So the answer is going to be D for this. Question number 11, guys. Question number 11. Yes. Question number 11, guys. So in the metal forming process, the value of stress required for continuous material deformation is known as. Is it ultimate stress? Is it flow stress? Is it proof stress? Is it true stress? Yes. Continuous material deformation. Yes, Tomato. So Tomato, Pudina have said the answer to be B. Yes, Kameshwari. What would be the answer? Yes. So the answer for this is going to be flow stress, guys. As you know, in the compression you have studied. As you know, in the compression you have studied. This is the curve which is coming. Okay. This is said to be the mean flow. Mean flow stress. Okay, guys. So the answer will be flow stress for the same. Because at flow stress, material continues to deform. Continuously to deforming it is. Question number 12, once again from flywheel, that is theory of machines. They are asking you the coefficient of fluctuation of speed, which is defined as delta n upon n mean. Okay, you need to find out this. What would be the answer? Yes, guys, solve it. Yes. Which question you are asking? पेनिट्रेशन तो इसमें कहीं है ही नहीं. Pudina, I didn't get your question. What you are asking about penetration? So first of all, what is this fluctuation of speed? Yes, delta n by n mean. You can see it is given that n1 is 180 rpm and n2 is 120 rpm. So guys, you know what would be delta n? 60 rpm. And what would be n mean? 150 rpm. So what would be the answer, guys? Okay, 0.4. Pudina is saying, tomato is saying 0.4. So guys, if you see that, see yes, 60 by 150. 0, 0 will get cancelled out. This will be 2 by 5. Answer will be 0.4. B is the right answer. Very good, guys. Moving to the next question. This is from the columns. This is from the columns. Once again, the question is from SOM. Okay. If you see both the papers of last year, penetration topic. अरे भाई पेनिट्रेशन तो आप एक वेल्डिंग में पढ़ते हो, मतलब यहां पर कौन सा पेनिट्रेशन आप बोल रहे हो? टमाटर, फॉर दैट जस्ट let's have a discussion on either phone or WhatsApp. I didn't get what you are asking. If you will tell me the topic clearly, I will take a session on that. There is no problem. Okay. So the end fixity coefficient is used in the crippling load equation based on Euler's theory of buckling of the columns. The value of the coefficient for the case one end is fixed, other end is hinge. So you know that when you define it, that buckling load is, you know, it is n square. Okay, let me tell you. It is pi square EI minimum upon LE ka square. Okay. So you know that, my dear, for this case, you know, this is the deviation will happen, and you can also write it PE when you will be putting it LE. So you know that LE will be L by root 2 for the same. So because of that, what would be the coefficient coming in the numerator if we take the standard formula as alpha pi square EI minimum upon L square? So can you tell me what would be the answer for this? Okay, Tomato is saying 2, very good. Ponina is saying 2, yes, it will be 2. Because you know that root 2 ka square will become 2. So here will be 2 will come. So that is nothing but the end fixity coefficient. So 2 is the right answer. Very good. Yes, moving to the next question, guys. This is from machine design, welded joint. This is from machine design, welded joint. This is from machine design, welded joints. What would be the answer for this one, guys? A double fillet weld is used to join the steel plates 5 mm thick for a length of 20 mm. The allowable tensile stress for the weld material is 100 MPa. The tensile strength of the joint is. You know that generally the tensile strength is given as, it is 0.707. 0.707 T into L into sigma permissible. This is generally the formula. So based on that, you need to answer it. What would be the answer? Yes, Pudina, Tomato. Tell me the answer, guys. Tell me the answer for this one. Very good. Both of you are saying 14.14. Yes, Kameshwari. Yes, Money, what would be the answer? So guys, when you will see this 0.707, thickness is 5 mm, length is 20, permissible is 100. So answer will be coming out to be 7.07 kilonewton. But my dear, they have mentioned the word double fillet. Double fillet, you need to multiply it with 2. So the answer will be 14.14 kilonewton. The answer will be C for this. Very good, guys. Moving to next question. This is from theory of machine. Balancing part. So guys, let us see how many of you give the right answer for this one. So guys, this is the 15th question going on. I will be there up to 40 questions. After that, Vipin sir and Chandra sir will be coming for the other parts of the paper. Okay. So tell me the answer for this. In a reciprocating engine, the primary direct crank is making an angle of theta. Then my dear, secondary direct crank will make what angle? Solve this, guys. Podina is saying the answer is A. What about others? So guys, like and share the session. What about others? Yes, Tomato Singh, what is the answer? You know that if we have this to be slider, this to be crank, when we are talking about primary direct crank, primary direct and then secondary direct. So my dear, if primary direct is making an angle of theta like this is primary direct, then there is primary reverse. Primary reverse will also make an angle of theta. Then there is secondary direct. Secondary direct is making an angle of just double 2 theta. Then secondary reverse is also making the angle of 2 theta. So always remember, the secondary direct is making the angle 2 times. Okay, because how we calculate it, you know, the unbalanced force is written as mr omega square cos theta plus mr omega square cos 2 theta by n. So you know, this is primary unbalanced force, this is secondary unbalanced force. So in secondary we have 2 theta. So the answer for this is D, guys. Wonderful. Now next question is from engineering mechanics, from trusses topic. You can see we have covered everything. Everything is covered. And the formula for that is m is equals to 2j minus 3. Use this formula and get the answer. M is equals to 2j minus 3. Use the formula and get the answer, guys. Here M is nothing but the number of members. M is nothing but the number of members. And J is nothing but the number of joints. Number of joints. Solve it and get the answer, guys. Yes, yes, yes. Yes, tomato, pudina. So guys, they are saying 5 members. So M is equals to 5 and 4 joints. This is also coming 5. When left hand side is equals to right hand side, it is going to be what? It is going to be perfect frame. So the answer will be C for this. Moving to the next question, guys. Question number 17. This is saying that a body which can retain its shape and size even when it is subjected to the external forces. This is a previous year's question of HPCL. I want to show you that whatever level we are discussing, the same is the HPCL. So I have intentionally added some question from last year. Tomato, Pudina are saying the answer is B. Yes, the answer is B, which can retain its shape and size. It is not rigid body. Rigid body means deformation not there. When deformation is there but retention is there or regaining is there, then we will call it as elastic body. So the answer for this is nothing but elastic body. Yes. Question number 18, guys, once again from material science. They are asking you the crystal structure of ferrite. Crystal structure of ferrite. Very good, tomato. So if that is the case, you will definitely be selected in HPCL, don't worry. Okay, but the point is their time is limited. You need to solve 170 question in 150 minute. So the point is the time you will get is very, very less. Okay, even you are not getting 1 minute for one question. Yes, Jovian, you are saying C. Okay, so I would like to say, guys, whenever we are going to have the cooling curve for iron, so I am telling you that this is the melting point temperature 1535. Then my dear, here you get delta iron. Delta iron is also known as ferrite. It have BCC structure. This is up to 1410 degrees Celsius. Then this is 900 degrees Celsius. Here it is nothing but gamma iron. It is having FCC structure. Then my dear, after this, here you will be having alpha iron. And this, when we are talking about alpha iron, here also alpha iron only. So this is also said to be ferrite. And this is once again have BCC structure. So the answer will be BCC. D is correct one. Okay? Yes. So D is going to be the answer. I feel you got it. Now the question is from vibration. As I said, we are covering all the topics. Vibrations. A vibrating system consists of mass of this, stiffness is this. Natural frequency is root K by M. What would be the answer? Solve it and get the answer. Yes, very good guys, very good. So solve it and get the answer, guys. Solve it and get the answer. Yes. Very good. So if you see this, stiffness is mentioned as, it is 80 Newton per mm divided by 200 kg. But you know it is per mm. To make it in per meter, I will multiply it with 1000. So when you will solve it, the answer will be coming out to be 20 radians per second. You can see without calci you are able to do everything. Okay? Yes. Next question is from welding now. Now we reach to welding. That is production. Okay, what would be the answer, guys, for this question? What would be the answer, guys, for this question? This is oxyacetylene gas welding. So they are asking you the temperature of the flame in the gas welding. What would be the right answer? Yes, Pudina, in the previous question, this is omega and asked. So this is 80 Newton per mm. This is 200 kg. So we have converted it 80 Newton per meter. For that you will multiply it with 1000. That is what I have done. Okay, so omega n is having the unit of radian per second actually. Okay. Yes. Okay, Pudina is saying 31,000 or 3100. Okay, Sandbok. Very good, very good. So the answer is 3200 degrees Celsius. Because my dear, you must be aware that when we are talking about oxyacetylene welding, it is 3380 for for, you can say there is three types of flame, na? Oxidizing flame. This is for oxidizing flame. Then it is around 3180 around for neutral flame. Then 2980 is for carburizing flame. So the range is around 3200. D will be the right answer. Okay, screen is not visible. Just refresh it, dear. Just refresh it, Sandbok, because from my side it is going properly. Is there any issue for others as well? Okay, very good, Pudina. This is from machine design. They are asking you notch sensitivity factor. Notch sensitivity factor. So what would be the answer, guys? Flame color, if you are talking about, dear, for three flames, when you are talking about, one is bluish color is coming, okay. White is coming in the case of carburizing, okay. Yes. So what would be the answer of notch sensitivity factor? Tell us the right answer. Pudina is saying A. Yes, tomato is saying A. Sandbog, now it is clear. Just refresh it. Yes, A is going to be the answer, which is correct. It is Kf minus 1 divided by Kt minus 1. You know Kf is actual stress concentration factor. Okay. And Kt is theoretical stress concentration factor. So A is going to be the right answer for this. So next question is related to gears, guys. Next is related to gears. So a gear tooth profile generated using curve traced by a point on the circumference of a circle that rolls without slipping on a fixed straight line is known as. Yes. What would be the answer for this case? Epicycloid, hypocycloid, cycloid, or involute? Yes. Tomato Singh is saying D. Okay. What about others? What about others? D lock kar de. Okay. So my dear, I am telling you about two profiles, involute and cycloid. So my dear, when you have a circle which is fixed circle, this is said to be base circle, and we have a line on this, and that line is having pure rolling motion on this circle, then the locus of any point on this line is nothing but involute. But when we are talking about cycloid, for this case we will be having the circle to be fixed, and on this circle a small circle will be moving, okay, and when it will be moving, the locus of any point of this will give you the cycloidal profile. So here they are saying a point on circumference of a circle that rolls without slipping on a straight line. So when this circle is having very big radius, it will become a straight line. So on this fixed straight line, when the circle is rotating or having pure rolling motion, then the locus of any point on this will be nothing but cycloid. So when circle is fixed, then my dear, we will call it involute. But when line is fixed, we will call it cycloidal. So the answer is C for this. Yes. Is it clear? So my dear, when we are talking about epi and hypocycloid, if in place of this straight line you take the circular, so you know one profile will be inside the circle, one will be outside the circle. So then this is said to be epi and hypocycloid. So epi and hypocycloid are the two parts of cycloidal profile. Okay. Is it clear, Podina? Shekhar Chandra, very good. The answer is C. This question is from casting. I told you we have covered all the topics. Yes, now is it fine? Sandbook, just I feel anybody else is also facing any quality issue with the video, please tell me that. Because from my side it is showing perfectly fine. Yes, solve this question. Shekhar Chandra is saying B. Modi ji is also saying B. Very good. So Pudina, Tomato, what do you say? The answer for this. You are going to make the pipes of uniform thickness. Okay, so the answer for this is going to be nothing but centrifugal casting. And in centrifugal also it is said to be true centrifugal. It is said to be true centrifugal casting. Okay, very good guys. Moving to the next question. So this is once again from machine design. Design of shaft. They are saying that the bending moment applied on a shaft is 30 Newton mm and twisting moment applied is 40 Newton mm. What will be the equivalent twisting moment? You know the formula is this. Apply the formula, get the answer. Podina is saying A, Shekhar Chandra is saying A, very good. So guys, we are still left with many questions because you know total is 85 question. Around 40 I will be taking. Tomato Singh is saying A, Podina is saying A, Chandra is saying A, very good. Modi ji is also saying A. When Modi ji have said A, answer will be A. Okay, it is going to be 30 ka square plus 40 ka square. The answer is 50 Newton mm. So you can see no calculator is required for the same. Now once again from the casting. This is from solidification time. Tell me the right answer guys. Yes. So Modi ji, Tomato, Podina, Shekhar. Yes. What would be the answer? Kameshwari. What would be the answer for this? Podina is saying A. Shekhar is saying A. Modi ji is saying A. Okay. So my dear, you know the solidification time is defined as K into volume but a surface area ka whole square. So the answer for this is no doubt about that is A. You are correct. Question number 26 from engineering mechanics. They are saying there are two forces F and F. They are acting on a particle at an angle of theta. You need to find out the resultant of them. Very good Modi ji, but आप K लगाना भूल गए. You forget about solidification constant. Solve this one guys. Now this is an engineering mechanics question. I will make it easy for you. You put one force here, other force here. They are making the angle of theta. You know the resultant will be like this. This is F, this is F. This is the resultant. You can see this one is F cos theta. And this one is F sin theta. You need to find out the resultant. Try to solve it. It is a good one. Happy family is saying C. Shekhar is saying C. Very good. Yes, Modi ji, क्या कहना है आपका? Podina is saying C. बहुत ही बढ़िया. So you will say resultant is nothing but, you know, this ka square plus this ka square. It is F plus F cos theta square plus F sin theta ka square. So the answer will be coming out to be 2F cos theta by 2. Why this will come? Because you know this is F square plus F square cos square theta plus 2F F cos theta and F square sin square theta. So you know in the square root what you will be having? F square plus F square cos square theta plus F square sin square theta is 1. F square plus 2F F cos theta. So 1 plus cos theta is 2 cos square theta by 2. So you will be getting the answer to be C for this. That is right. Moving to 27th. This is related to the vibration, damped vibration. Very good Modi ji. So this is from damped vibrations. Damped vibration. Okay, in the damped vibration you need to find out the ratio. Logarithmic decremental ratio. How it is defined? Yes. Dhalapatti ji is saying B, Shekhar Chandra is saying C. What about others? What about others? Yes, what about others? Podina is saying B. Okay. Rahul Gandhi. Very good. B. अभी केजरीवाल जी भी आने वाले हैं. Modi ji C. Tomato Singh B. Shyam Kiran is saying B. So guys, the answer for this is log x naught by x1 or x1 by x2 or xn by xn plus 1. So you see the answer is going to be B for this. This is once again from material science crystal structure. For FCC, what are the average number of atoms? Average number of atom for FCC. Coordination number nahi, Shekhar. Average number of atoms. Yes, very good. For last question, answer is B. Very good. So what is the average number of atoms for FCC? Yes. Dhalapatti, Rahul Gandhi, Pudina Yadav, Shekhar Chandra, Happy Family, Modi ji, Tamatar Singh, Shekhar Chandra. Very good. The answer is going to be 4. You know that for FCC the average number of atom is 4. For BCC the average number of atom is 2. For simple cubic it is 1. And for HCP it is 6. These are the average number of atoms. So the answer is A for this. Sorry. Yes, A for this. Question number 29, guys. This is from assumption of Sohm. Assumption of Sohm. This is also previous year's question. And it is also, you can say, from engineering mechanics type of forces. This question is from assumption of Sohm, you can say, or it is from engineering mechanics and it is a previous year's question. So I want to show you the exact level of paper. Yes, Shekhar is saying D is the answer. Dhalapatti ji is saying D is the answer. Yes, Pudina Yadav is saying D. Happy Family, Rahul Gandhi, D. Very good. Bahut hi badhiya. Tamatar Singh, D. So the answer is D, guys. Because you know that when we are talking about the forces, there are two forces. One is surface, other is body. Body forces are those for which every point give its contribution. So only in volume you can count every point. So my dear, these forces are nothing but the weight, but the centrifugal force. Okay. So the answer is D for this. Very good. So guys, next is question number 30. Once again from strength of material. You need to find out the change of volume. Okay, so this is the question, very easy. You also know that volumetric strain is epsilon xx plus epsilon yy plus epsilon zz, and it is also given by dV by V. So you need to find out the value of dV, solve it and get the answer. Solve it and get the answer, guys. Solve it and get the answer. Rahul Gandhi ji saying the answer is C, बहुत ही बढ़िया. Podina is saying C, बहुत ही बढ़िया. Modi ji आपका क्या कहना है? राहुल जी आपका क्या कहना है? Tomato is also saying C. Okay, Rahul Gandhi ji already कह चुके. Answer is C. Very good. So the answer is C. When you will add this, you can see 0.0065, 0.0025, 0.002. Okay, so it will give you 0.01. Okay, this will give you 0.01. So you will be having into volume 100 cross 25 cross 20, you will get the answer. Okay, very good. Next question, guys, 31. This is from metrology. This is from metrology. Production again. I told you we have covered all the topics. Question was there from SIM as well. This is from metrology. Okay. Material science is already there. Casting, welding we have already seen. Metal cutting will also come. Don't worry. Dhalapatti ji is saying the answer is A. Very good. Shekhar is saying A. Very good. हाँ भाई मोदी जी, राहुल गांधी, टमाटर जी. Modi ji is saying okay, nothing. Rahul ji is saying 31A. Okay. So my dear, if this is the nominal size line, Okay, if this is the nominal size line, you have any size, upper limit deviation is always said to be upper deviation. Lower limit deviation is always said to be lower deviation. So the answer is upper deviation. Next is from metal cutting. Once again the question is from production. The value of N for ceramic tool is, the value of N for ceramic tool is, yes, पुदीना is saying C, राहुल गांधी C, धालापत्ती जी C, शेखर चंद्रा C, बहुत ही बढ़िया, बहुत ही बढ़िया. So guys, the answer for this is C. This is for ceramic, this is for carbide. Okay, you know N value depends on the tool. Very good guys, बहुत ही बढ़िया. Question number 33 once again from machine design. This is from the design of clutches. Uniform wear theory formula. Yes. Let us see how many of you give the right answer guys. बहुत बढ़िया. हाँ भाई, मोदी जी, राहुल जी, पुदीना, टमाटर, धालापत्ती. Okay, शेखर Chandra is saying the answer is B. Okay, what about others? Rahul Gandhi is also saying A. Okay, what about others? Okay, BA. I am telling you, generally the formula is mu WR. Okay, this is the normal formula when we are using. But when we are going for UPT and UWT, my dear, then T for UPT is coming out to be 2 by 3. Mu WR mean. Okay, here R mean is defined as R naught cube minus Ri cube by R naught square minus Ri square. Okay, this is how you are going to define. T of UWT is defined as 1 by 2 mu WR. So if you are going to write it R, it is fine. Otherwise, when you will be putting it, this is half mu WR. It is coming when inner radius is 0. Otherwise, when you will define it, it will be coming out to be mu W R naught minus Ri. Okay, so what I want to say is here, they have already mentioned that single plate disc clutch is used to transmit the torque axial load W. The mean radius of the surface of friction material is R. So what they have given R as, it is the mean radius. So the answer is going to be 1 by 2 mu WR for UWT and 2 by 3 is there for UPT. So the answer is going to be B for this. Is it clear? So the answer is going to be B. Very good, Modi ji. So guys, to register for the workshop, link is there in the description box. Moving to question number 34. 6 questions are left from my part. Then Vipin sir and Chandra sir will be coming for other subject. So question number 34. The lattice structure of titanium is. The lattice structure for titanium is. This type of question have also been asked in GATE as well. Lattice structure of titanium is. Yes guys, what would be the answer for this? Tomato is saying B, Rahul is saying B, Modi ji is saying B, Pudina is saying B, and yes guys, the answer is closed packed hexagonal. So for this crystal structure is HCP. HCP is the right answer. Very good. Question number 35. This is from strength of material again. This is from strength of material again. And circumferential stress is given as PR by T or PD by 2T. PR by T or PD by 2T. Put the value, get the answer. Put the value, get the answer. Yes guys. Pressure is 2 MPa. Diameter is 500 mm. 2 times of thickness. What will be the answer? Okay. So everyone is saying, sir, the answer is going to be A. So the answer is going to be 50 MPa. Wonderful, guys. It's really nice. Let us move to the next question now. Question number 36. Once again, the question is from vibrations. Question is from vibrations. The critical damping is said to occur when the frequency of damped vibration is. You need to tell whether in the critical damping vibrations are there or not. Because if vibrations are there, then only the frequency will be there. Yes. Rahul Modi ji. हाँ, पुदीना, टमाटर, शेखर चंद्रा. Yes. Very good. So when we are talking about the critical damping, in critical damping vibrations are not there. So when vibrations are not there, how frequency can be there? The answer is 0 for that. Okay. Very good. Question number 37, guys. Question number 37, guys. Question number 37. Once again, from the vibration, they are asking the transmissibility of a vibrating system when R is more than root 2 will be. When R is more than root 2 will be. जब R root 2 से बड़ा होगा, then what would be the value of transmissibility ratio? Shekhar Chandra is saying the answer to be B. So guys, do like and share the session. We are about to complete 40 questions. Podina is saying B. Dhalapatti ji is saying B. Rahul is saying B. Shekhar is saying B. So guys, when you see the diagram, the graph between transmissibility ratio and R, the graph is coming like this. The graph is coming like this. Okay, like this. Like this. So if you see, this is root 2. After root 2, it always remains less than 1. So the answer is B for this. Very good. Moving to the next question, 38. Soderbergh machine design fatigue loading topic. Yes, guys. So in the Soderbergh method, a failure stress line connects the endurance limit for reversal loading with yield strength, variable stress, shear stress or ultimate stress. What would be the answer for this one? Yes, guys, do answer it. Shekhar is saying A, Rahul is saying A. बहुत ही बढ़िया. So guys, when we are talking about, there is a graph between amplitude stress and mean stress. That is said to be fatigue diagram. Soderbergh line is like this. Goodman line is like this. So if this is SYT, this is SUT. Soderbergh, Goodman. This is endurance. So guys, the answer is A for sure. Okay. So my dear, failure stress line connect the endurance limit with the ultimate strength. Sorry, yield strength for the Soderbergh. For Goodman, it is with ultimate. So this is ultimate, this is yield. So the answer is A. I feel Shekhar and Rahul Gandhi have given the right answer. Modi ji kahan chale gaye bhai? Question number 39 once again from strength of material. They are saying that if we are applying this type of loading, what will be the normal stress at any arbitrary plane? Yes, if this is sigma xx, what will be the value of sigma theta? Very good. Nivesh is saying D. Very good. So guys, you know, when you find out sigma theta, it will be sigma xx cos square theta. And when you find out tau theta, it is sigma xx by 2 sin 2 theta. The answer for this is going to be D, guys. Okay. पुदीना भाई चारों कैसे हो जाएंगे आंसर? Yes or no? So my dear, the answer is going to be D for this. Okay. Let us move to the question number 40, guys. So a specimen made of ductile material subjected to tensile stress has maximum shear stress on the plane inclined with an axis. So my dear, they are asking you if we are going to apply this with the tensile stress like this, shear stress will be maximum at a plane with angle. Or they are asking plane of maximum shear will lie at. Senbok is saying 45. Dalapatti is saying D. Shekhar is saying D. Podina, very good. So my dear, when you see this, you know that plane of maximum shear are at 45 degree to the principal plane. So if this is direction of one principal stress, this is direction of second principal stress, then at 45 degree to both of them, we will be having tau max plane. So the answer for this is D. Okay. So actually 40 question I was about to take, but I am giving you 2 to 3 bonus question from my side. Okay. Then Vipin sir will be joining, Chandra sir will be joining for other subjects. Okay. Actually total are 85 questions. So I was about to take 40, but I am taking 2 to 3 extra questions. Can you tell me what is the number of atoms in BCC? Average number of atoms in BCC. Very good, very good. Modi ji is saying 2, Shekhar is saying 2. So guys, the answer for this is 2. BCC have 2 atoms per unit cell. This is from theory of failure. This is the last question from my side, guys. Last question from my side. A brittle material will fail when the maximum tensile stress reaches a value of ultimate normal stress subjected to simple tension. This is the theory of. Which theory takes maximum value of normal stress as the failure criteria? Which theory of failure takes the maximum value of tensile stress as the failure criteria? Shekhar is saying B. Sandbok. Yes, Sandbok. Tomato, Pudina, Rahul is saying B. Okay. Tomato is saying B. Modi ji. Pudina Yadav is also saying B. बहुत बढ़िया. Modi ji is saying B. बहुत बढ़िया. Mohammad Sahil is saying B. बहुत बढ़िया. Dhalapatti ji is saying B. So guys, B is the right answer. B is the right answer. Very good. So, okay, one more question. Let us see. The unilateral system of tolerance. Tolerance is allowed on which side? Yes. This is again from metrology. So in a unilateral system of tolerance, tolerance is allowed on which side? One side of actual side, one side of nominal size. So guys, when we are talking about unilateral, this is nominal size. And in the nominal size, either tolerance will be on this side or tolerance will be on this side. Then it is said to be unilateral. So the answer is A for this. Okay. Yes. So I am feeling happy. Let us see one more question. Okay, this is from column. So these 4 to 5 questions are extra from my side to you guys. So when both ends are fixed, then equivalent length is. Both ends are fixed, then equivalent length is. Dalapatti is saying B, Shekhar Chandra is saying C. So the answer is C, because you know when we take both end fix, then it is going to be like this. Okay, C will be the right answer. Very good. This is finally the last question from my side. After this, Vipin sir or Chandra sir will be joining for the other subjects. This is last question from my side. The PDF of this session will be available on my Telegram channel, Mechanical by Dheeraj Sir. There you can get handwritten notes of all the subjects of mechanical engineering, as well as you will get previous year's questions, and also you will get some other daily practice papers which I am going to upload on alternate days or daily basis. So this is saying for vibrating, the maximum kinetic energy at the mean position is equals to the maximum potential energy at the extreme position. The statement is the basis of. Yes, the statement is the basis of relay method. Yes. Fine. So guys, I would like to say that energy conservation is the base of energy method, you know. Equilibrium method is the Newton method we have seen. Okay, relay method is also said to be static deflection of mass. So answer is correct. So guys, with this we have completed these questions. Reed's method is not in your syllabus. Okay, Reed's method is not in your syllabus. So guys, I am leaving here. Now Vipin sir or Chandra sir would be joining to continue the session for other subject topics, okay, or questions. So goodbye from my side. Now sir will be joining. So just wait.
Hi everyone, how are you? I am Vipin Kumar and I welcome you all to the India's most comprehensive preparation platform for GATE and ESC. So this session started at 12:30, right? And already 1 hour is gone. I think you have already solved 40 questions, and I really hope 45 questions. Yeah, I got to know. Anyway, so I hope you had a very nice time with Dheeraj Sir, and you had a good practice session. We are going to continue this session now with the problems of thermodynamics, basics and applied. Okay, so let's move on, and few announcement. There is a Achievers series that you can join if you are preparing for also GATE 2023. You can get the details on the YouTube as well as on the app. And also very important session for the people who are preparing for GATE 2023. There is a 121 days strategy taken by Joshi sir, and it is on the app. So you can register on the app to attend this session. Okay. So just a brief introduction. So I have around 4+ years of teaching experience. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. I have around 3.5 years of research and industry experience. And my area of expertise, as you all know, who have attended my session, is thermodynamics, basics and applied, and heat and mass transfer. Okay, you can also join my Telegram channel. I keep posting my schedule there, YouTube schedule, app schedule and everything. Also my notes and PPTs. Okay, so I hope you are all excited enough to start the session. We will take 20 questions, right? And we will try to finish this session in next 30 to 35 minutes. Okay, that is the ideal time. Okay, now, so let's start the session. Okay, very first question. I hope that you answer this question in less than 45 seconds. So I've started a timer, and very quickly you have to answer. Good afternoon, Rahul. Very quickly you have to answer. You read the question, you solve it in 45 seconds. Now 35 seconds are left. Okay. So read the question very quickly and answer within the time limit, because it is very important that accuracy and speed both are important. C is the correct answer. Why C is the correct answer? First law is entropy. No, why? D is the correct answer. Yes, Rahul, Shekhar, Mohammed, C was not the correct answer, okay? And I would also request everyone to please write the question number, okay? Question number 41, or write 41A, 41B, whatever you want to write the option, but please write the question number so that we can avoid the confusion that we have in the question numbers, okay? Yes, tomato and podina, okay, right. Okay, so good afternoon, sir. Good afternoon, Amala. Thank you very much. We all try to be helpful for your preparation. Okay, so yes, we all know that first law is related to internal energy or energy conservation. These terms are basically whenever you see or total energy. Okay, so first law is related to either internal energy, energy conservation, total energy. So these terms are related to first law. Okay, so here we have internal energy. Second law, we all know either quality of energy or entropy, okay, or direction of energy transfer. And zeroth law is, we all know, absolute temperature. And zeroth law is temperature. And third law is absolute temperature, okay. We all say that at 0 Kelvin, that at absolute zero temperature, the total entropy will be 0. It will be the dead state of any system. Okay, so it is absolute zero temperature, and the right answer is D. Very nice. B, okay, B, why? B is not the correct answer. D is the correct answer. Okay, let's move on. Let me recheck. P is to 2 and Q is to 4. Yes, R is to 3. That is very good. So D is the correct answer. Yes. Okay, let's move on. In a steady flow, and the timer is on already. You read the question. In a steady flow, reversible adiabatic. Steady flow, reversible adiabatic. Work done is equal to. Write the question number 42 and the option. Okay. I'm just writing the equation here. 30 seconds are left. 30 seconds are left. Steady flow energy equation is H1, and we are neglecting kinetic and potential energy. What is the answer? Change in enthalpy. Yes, Rahul, very nice. 42B, change in entropy, no. 42A, no. Change in internal energy is for a what? For a closed system. Steady flow are for open systems, and it is change in enthalpy, okay? Plus Q is equals to H2 plus W. And this is net in, this is net out. Okay, so if it is a reversible adiabatic process, that means we can neglect this, and net work will be equal to change in enthalpy. Change in enthalpy, this is your net work output. Okay, change in internal energy is for closed system, not open system. What about heat transfer? What about heat transfer? That is for isothermal process in a closed system. Okay, be very clear about it. Yes, Podina, that is correct. Rahul, yes, that is correct. Okay, Rahul, yeah, that is 42C is the correct answer. Okay, very nice. Try to follow the time limit. It's very, very, very important. As Dheeraj Sir has already told you, I think, that you have to solve 180 questions in 150 minutes. Less than 1 minute, you have to solve one question. You have to read the question, judge the question, and mark the question. Also, you have to, encircle your answer sheet as well in that time. So, be very quick. Speed and accuracy both are important in HPCL. Okay, in GATE, accuracy is much more important than speed. You have more or less enough time to solve the 65 questions. Okay, but in HPCL or any PSU exam, it's very, very, very important that you take care of accuracy as well as time. Okay. Now, question number 3, and the timer is on. Timer is on. Question number 43. In a Carnot engine, T1 is the higher temperature, T2 is the lower temperature. Most efficient way to increase the efficiency. T1 ko बढ़ा दो, increase the T1, decrease the T2, increase both T1 and T2. 25 seconds are left. 43. What is the right answer? 43. efficiency of a Carnot engine is what? T higher minus T lower upon T higher. 43, right answer. 10 seconds are left. 43, D, no. Podina, that is not correct. 43, no, that is not correct. Or I can say T1 by T2 by T1. T1 is the higher temperature, T2 is the lower temperature. So you see, 43B is correct. Yes, Mohammed Sahil, 43B is correct. So you see, if you are increasing T1, so your numerator is increasing. Yes, efficiency will increase, but your denominator is also increasing. Your numerator and denominator both are increasing. Okay, so you are not sure that if how much it is going to increase, but if you are increasing T2, that means lower temperature. That means only numerator is going, if you are decreasing T2, that means only your numerator is going to increase, your denominator will remain same. That means your efficiency will have a higher increase. Okay, so decreasing T2 is much more efficient than increasing T1. Okay, decreasing T2 is much more efficient than increasing higher temperature T1. Okay, so the answer is B. Okay, 43B, yes, Shekhar, that is correct. B is the correct answer. Who said C? No. Why? What was the doubt? Even Tomato said C. Why do you people come up with these creative names? Okay, Rahul again. Okay, this is 43, right? 43, Podina said D. No, D is not correct. And B, Shekhar and Mohammed are correct. Okay. So, as I already told you the logic, if you are increasing the T1, then both numerator and denominator is increasing. So maybe it can increase, but how much, I am not sure. But if you are decreasing the lower temperature T2, it gives you much higher efficiency than the increasing T1. Okay, right? Purane name hai. Okay. Anyway, question number 44 and the timer is on. We all know path function. We all know point function. We all know exact differential, inexact differential. We study this in the basics of thermodynamics in the very beginning. Okay, pick up the correct statement regarding path function. So we are talking about path function. What are the examples of path function? Heat and work transfer are path function. What are point function? Any property, temperature, pressure, enthalpy, internal energy, all are properties. Okay, all are point function. So when we talk about path function, 10 seconds are left. 44, see the differential of path function are inexact differential. That is correct. That is absolutely correct. 44 is C, not Muhammad. D is not correct. The differential of path function are not exact differential. 44C is correct. 44C is correct. Yes, Tomato and Podina. 44C is correct. Okay. So whenever we talk about, let's start with point function. Okay. If we have a point function, so what we can write, that D2 minus T1. I know that it can be confusing, but I can give you the example. For example, if you talk about internal energy, that is a point function, that is a property. So I can write U2 minus U1. When I say DH enthalpy, I can say H2 minus H1. Similarly, DT temperature, I can say T2 minus T1. These are all point function. But when I talk about path function, so this is called as exact differential. This is called as exact differential. But when there is a path function, for example, work transfer, heat transfer, so you cannot write it like, this is not equal to D2 minus D1. It is not equal to, for example, dW, work transfer, you cannot write W2 minus W1. Either you write PdV, then you integrate it. You cannot write W2 minus W1. Similarly, dQ, Q2 minus Q1 you cannot write. You have to calculate it by integrating. In the TS diagram, you have to integrate. Okay, so you cannot write that. So, and this is called as inexact differential. When it is not equal to D2 minus D1, final state minus initial state, it is called as inexact differential. Okay, 44C is the correct answer. Very nice. Let's move on to question number 45. Question number 45. The shortcoming of the first law of thermodynamics. What is the shortcoming of the first law of thermodynamics? Why we have to come up with the second law of thermodynamics? Why the first law of thermodynamics was not enough to determine the energy conservation, energy conversion? Okay, 45D is the correct answer. Yes, Podina, that is absolutely right. And I forgot to start the timer anyway. Okay, so very nice. Okay, so shortcoming of the first law is it only talks about the quantity of energy. Okay, it tells you that if you have if you have one unit of energy, you can convert it. But how much can you convert into another form? First law cannot tell. Or will it be able to convert completely or partially? It cannot tell. So it does not tell you about the quality of energy. It does not tell you about the direction of energy transfer, and it does not tell you even if it is going to happen or not, possibility or feasibility or spontaneity of process. It cannot tell. It only talks about the quantity of energy. That is the shortcoming. Second law is about direction. Yes, second law is about direction. It is about the quality of energy. It is about the possibility that water will only flow from in the downward direction, from up to down. It can never flow naturally in the opposite direction. Okay, so these are the things only second law tells you. According to first law, it is equally possible for the water to come down and to go up. First law doesn't care about the direction of the process. Okay, so it is absolutely right, quantity of energy. Okay, let's move on to question number 46, and the timer is on. In a steady flow process across the control volume, mass and energy flow varies. Steady flow process, steady flow. So if I have a system and this is a open system, okay, steady flow process, B is the correct answer. Chaudhary, yes. Rahul, 46, B is the correct answer. Muhammad, yes. Very nice. 46, B is the correct answer. So we all know that in a steady flow process, both the equation, energy conservation and mass conservation, applies. Okay, so change in the mass, if it has some mass m1, initial mass m1, and the final some mass is coming in, m in, and some mass is going out. So change in mass in the system, in the open system, will be equal to 0. So m2 will be equal to m1. Inside the system, mass will remain constant, because whatever mass is coming in, the same mass is going out. That is called the mass conservation. There is no change of mass inside the system with respect to time. Similarly, energy conservation, whatever energy is coming in, energy in will be equal to energy out, and that means therefore E2 is equals to E1. Inside the system, the energy is not changing. Whatever energy is coming in, the same energy is going out. So the change of energy inside the system will remain constant. Okay, clear? Level increase karo, sir. Level, this is the level for HPCL, yeah. I mean, if I bring gate questions, there is no use of that. Okay, very simple questions come. Can you please increase speed? Yes, but explanation is also required, right? We are already on a very high speed. Okay, 47. The energy, some numericals are also coming in between. Okay, so 47 and the timer is on. Tell me very quickly. Statement 1, the energy of isolated system is constant. And statement 2, the entropy of an isolated system can increase but cannot decrease. Which one is the correct answer? 47, A, B, C, D. It is C. Why C? This is the first law. Of thermodynamics. We have universe is an isolated system, and the energy of the universe is constant. No energy will be created or destroyed. Only energy conversion can take place. 47D is also not correct. Podina is absolutely correct. 47B is correct. Okay, and this we talk about in second law. Okay, we all talk about this, that entropy change of universe or entropy change of an isolated system is always greater than equal to 0. It is equal to 0 for a reversible process and it is greater than 0 for an irreversible process. Okay, so entropy of a universe never decreases or an isolated system never decreases. Either it remains constant or it increases. Okay, it cannot decrease. So both are true. Statement 1 and 2 both are true. But 1 is not the correct explanation or 2 is not the correct explanation of 1. Okay, so B is the correct answer. We are on a good speed, yaar. Come on. Okay, let's do this. The timer is on. A system absorbs 100 kilojoule as heat and does 60 kilojoule work along the path 1, 2, 3. The same system does 20 kilojoule work along the path 1, 4, 3. The heat absorbed we need to tell. Okay, so 25 seconds are left. Look, Rahul, I have to explain also. I can understand that you can just mark the answer, but I need to explain for the people who do not know the answer, correct answer. Okay, so you can increase the speed. For me, it's a restriction. 48 is D. I think that is correct. That is correct. Okay, so I hope you all know that for process 1, 2, 3, I can say dq13 is equals to u13 is equal plus w13. Okay, if I am going through this path and this is 100 is equals to u13 plus 60. So u13 will be 40, right, kilojoule. Similarly, if I talk about process 1, 4, 3, now I can say q13 again is equals to u13 plus w13. Now the values of heat and work transfer will change. The initial and final condition is same, right? So because heat and work transfer are path function, so because you have changed the path, so their values are going to change. But the value of internal energy is not going to change. If the initial and final condition is same, the value of internal energy will remain same because it is a property. It is a point function. It only depends on initial and final condition. It does not depend on what path you are taking. Okay, so Q13 I need to calculate. This value will remain same, 40 plus now work transfer is 20. So Q13 is 60 kilojoule and people have already answered that D is the correct answer. Okay, 48 D is Sekhar, that is correct. Podina, that is also correct. Tomato, that is correct. Rahul, yes, that is correct. I know that you people have good speed. I'm really happy for it. Okay, but I have a restriction. Okay, I need to explain. Okay, now next question, and the timer is on. 45 seconds. We have a heat pump that absorbs from atmosphere. We have an atmosphere at 10 degree and an atmosphere is, and a room is to be maintained at 25 degree. So the lower temperature is 10 degree, the upper temperature is 25 degrees. Okay, but there is a temperature difference of 5 degrees exists between working fluid and the atmosphere on one hand and the other hand. So there is a temperature difference of 5 degrees on the both the ends. Now work given to the heat pump is given. Heat delivered I need to find out. Okay, so do I need to draw a diagram? Please write the question number, Podina, so that I know that what question you are answering. Okay, so 49 A B C D, 49 A B C D. This is my heat pump and I need to maintain a room at 25 degrees Celsius by taking heat from 10 degrees Celsius. Okay, and some work input that is given to me is 1 kilowatt. Okay, I am absorbing heat Q2 and giving heat Q1. So now they are telling me that there is a, look, this is not a reversible heat pump or a Carnot heat pump. if it is a Carnot heat pump, then the temperature in the heat pump, the working fluid temperature and the reservoir temperature will be same. But it is an actual heat pump. So my working fluid cannot operate at the same temperature of the reservoir. When I transfer heat from this 10 degrees Celsius, the temperature that is maintained in the working fluid that is working inside the heat pump in the components will be at some different temperature. So this is operating at a temperature difference of 5 degree Celsius. Similarly, this is also operating at a temperature difference of 5 degree Celsius. 49D is 49, let me check. No, that is not correct. Yeah, that is what, they are not saying it is a Carnot heat pump. They are saying it is a heat pump, it is an actual heat pump. Look, if it is a Carnot heat pump, that means, I hope you all know this, that in a reversible engine or a heat pump or a refrigerator, the temperature difference between the working fluid and the reservoir is infinitely small. We can assume that there is no temperature difference between the working fluid and the reservoir. But you see, my working fluid is revolving inside the heat pump. There are components. Okay, it is taking heat from a reservoir that is at 10 degree. Now when I am supplying heat, there will be some heat loss. Okay, so the temperature that is maintained in the working fluid will be less. Okay, so it will be around 5 degrees Celsius in the working fluid. So whatever working fluid is inside the heat pump, it is absorbing heat from 10 degrees Celsius, but it will not be able to maintain 10 degrees Celsius. Okay, it will be able to maintain only 5 degrees Celsius. Now similarly, I am giving work in the heat pump. So I am increasing the temperature of my working fluid in the heat pump so that it will transfer heat and maintain this room at 25 degrees Celsius. Now answer me a simple question. If I maintain a temperature that is less than 25 degrees Celsius in my working fluid, will my working fluid be able to maintain 25 degrees Celsius? Tell me. हिंदी में बता देता हूं मैं तुम्हें, अगर मैं अपने वर्किंग फ्लूइड में 25 डिग्री सेल्सियस से लेस टेम्परेचर मेंटेन कर रहा हूं, then will my working fluid be able to maintain 25 degrees Celsius or not? No, yes. So that means I need to maintain higher temperature than 25 degrees Celsius so that when I am supplying heat, some heat loss will happen, but still I will be able to maintain 25 degrees Celsius. Okay. So here temperature difference I will maintain 5 degree. So I have to at least maintain 30 degrees Celsius. 5 degree temperature difference is given. Then only I will be able to maintain my room at 25 degrees Celsius. Okay. So this heat pump is working between the temperature limit of 30 and 5 degrees. Now you can calculate the heat delivered. Okay. So we all know that COP of heat pump will be T higher upon T higher minus T lower is equals to Q1 upon W. Now do not tell me, sir, this is for Carnot. Yes, this is for Carnot. But the temperature that it is for Carnot only when you put reservoir temperatures here. But if I put my actual temperature here, then I can use it for my actual as well. Okay. So what can I write here? I can write 30 degree, which is 303, and 30 minus 5 is 25. Q1, W is given 1 kilowatt. So whatever you are going to get, now tell me what is the right answer. I hope this concept is clear to you. And I am not saying these types of questions are asked in PSUs. Okay. No, I don't think so. Just try to solve it one more time. Okay. I think, okay, just try to solve, because I think heat delivered you need to find out, right? So this is just 1 second, 303 divided by 25. Yeah. So what is the right answer? We converted, yes, A is the correct answer, irreversible to reversible. No, we did not do that. What I am saying is, if I need to calculate the COP of the Carnot or the maximum COP this heat pump will have, so what will I do? I will do 25, which is what? 298 upon 25 minus 10, this is 15. This is my maximum COP that this Carnot, if this heat pump is a Carnot heat pump, then I will get this COP. I don't know how much is this. Just you need to calculate. This is 298 by 15. So this is 19.8 kilowatt. So the maximum COP is 19.8. But here I am putting the actual temperatures. That's why I can use this formula. Otherwise you cannot use this formula. If only reservoir temperatures are known and actual heat pump is there, I cannot use this. I can only use this if I know the actual temperatures in which my heat pump is working. Okay. So is this clear? Is this clear? I did not convert it. I am putting my actual temperatures here, actual temperatures. And this is the reservoir temperatures. Okay. Is this clear? So Q1 is equals to 12.1 kilowatt, right? Okay, so let's move on to the next question. I know it took a lot of time, but very quickly, I have started the timer. If the COP of the Carnot refrigerator is 6, the ratio of higher to lower temperature is, tell me very quickly what is the right answer? 50 A, B, C, D. Which one is correct? COP of the refrigerator is equals to T lower upon T higher minus T lower. Okay. I can also write it 1 upon T higher by T lower minus 1. Okay. And this is equals to 6. So I can go here as 1 by 6 is equals to TH by TL minus 1 and TH by TL 1 by 6 minus 1. What is the right answer? What is the right answer? I'm sorry, plus 1. What is the right answer? Should I write it down? Very quickly tell me what is the right answer. D is the right answer. Yes, D is the right answer. 7 by 6. Okay. So this is 7 by 6. Okay. Let's move on to question number 51. Let's move on to question number 51. Now, a cycle is given. A cycle of PV diagram is given. PV diagram is given. And the TH diagram, I need to tell which one is the correct answer. I need to tell the TS diagram. Which one is the correct option? Which one is the correct option? Tell me. So from this diagram, I can conclude 3 things. Okay, first is that BC is constant pressure. Okay. The second thing I can conclude is that CA is constant volume. 51B is correct. Absolutely. Yes, Podina, that is correct. 51B is correct. Okay. D, no, D is not correct. I will tell you why it is not correct. Okay. So, and I can also conclude this. I know that the slope of constant volume is higher than constant pressure. So I can also say that the slope of CA will be greater than slope of BC, right? This much I can conclude by seeing my PV diagram. Now let's talk about option number A. So option number A is telling me that AC is constant temperature. But I know from here that my AC is constant volume, so this is not correct. So option number C tells me that BC is isentropic. Now here I know that BC is constant pressure, so that is also not correct. Right? Now I am not sure. Look, this B, I am not sure if it is isentropic, if it is polytropic or isothermal, because it looks like same. It looks like same. Okay. Now what I need to do, I need to work. Now here BC. Now here it is isentropic, and this could be a right option. Yes. AB could be isentropic, yes. By seeing this, it could be isentropic, it could be isothermal or polytropic, anything. So this is correct. And this is isothermal, so this could also be correct. Abhi tak I do not know what is the right answer. I am only judging that B or D could be correct. Now I need to see the slope. I need to see the slope. How do I see the slope? So you see, look, if I talk about this and this, so which slope is higher? BC or AC? So if I see option number B, I can say that slope of, I hope you all know how to identify the slope. Okay, if a line is more close to y-axis, it has higher slope. If a line is more close to x-axis, it has less slope. Okay, so I can say that slope of AC is greater than slope of BC. Okay, you see AC is more close. AC is more close to y-axis while BC is like this. So BC is more close to horizontal axis. Okay, nice. So you already knew this answer, right? Do not try to remember the answers. Try to come with the logic. I hope if you know the logic, it's good. No problem. Okay. So and this is matching our right option. But if we talk about option number D, and I extend this line and I extend this line, so now you see this AC is more close to, you see here AC is more close to horizontal axis while BC is more close to y-axis. So here I can say that slope of BC is greater than slope of AC, which is not concluded by my PV diagram. Okay, which is not concluded by my PV diagram. So B is correct. B is correct. Yes. We look, that is what we do. We have proved this. There's a derivation, but from there I know that the slope of constant pressure is less than slope of constant volume. Okay, there is a mathematical proof also for it, but we do it when we do conceptual wise. But I know the conclusion and I can draw it here. I know that the slopes are matching with my option B. Okay, now let's move on to the next question. 51 we have done, 52. Okay, now come on, what is the ratio of efficiencies? We have two cycles, cycle A, cycle B. Okay, so we need to find out efficiency, the ratio of efficiency 1 by ratio of efficiency 2. What is the right answer? What is the right answer? So I will also solve it with you, right? But I have, let's say, 45 seconds. Look, these questions, some questions take time. Some questions require 10 seconds, 15 seconds. So you can save time there so that you can utilize that time somewhere in the longer questions. Okay. So now if I talk about the efficiency of this, it will be work done by heat supplied. Okay. Now what is the work done? Work done in this cycle is the area under this curve. Okay. So I can say it is 1 upon T1 minus T2 by S1 minus S2. Now what is the heat supplied? So heat supplied is, one second, let me, okay, so green color, okay. So the heat supplied is all the area under this. This is my heat supplied. Now how do I know this? 1 by 2 T1 plus T2 by S1 minus S2. This is my 52D is correct. That is correct. Yes, 52D is correct. Okay. What about this efficiency of second cycle? Now again, work done is the area inside the curve. Okay. So I can write, what can I write? It is same. Work done is same for both the cycles. T1 minus T2, S1 minus S2. Okay. Now what is the heat supplied? Now heat supplied here is what color? Green color. Yes. heat supplied is this whole area, so it is a rectangular. Okay, so I can say it is T1 S1 minus S2. Okay, now I can do this, efficiency 1 by efficiency 2. So work done is same, work done will be cancelled. Okay, so do I need to write everything? But let's not write everything, but what can I do? Let me write T1 S1 minus S2 upon half T1 plus T2, because work done is same, work output is same for both the cycle, it will get cancelled. Okay, only heat transfer will remain. S1 minus S2, this will get cancelled, and finally you will get 2 T1 plus T2, right? So that you need to find out, we do not know that. Okay, so D is the correct answer. Let's move on to the next question, 53 question. The entropy will usually increase when? The entropy will usually increase when. Now there are 5 options, and A, B, C, D we need to know. The timer has started. Now you need to tell me the correct answer. Entropy will usually increase. Entropy will usually increase. Entropy, a molecule is broken into 2 or more smaller molecules. A reaction occurs that results in increase in the number of moles of gas. Okay, process is adiabatic, process is reversible adiabatic. A liquid changes to a gas. Okay, so C is the correct answer. Yes, Chaudhary, that is correct. The only possibility when the entropy is not going to change, is first when it is reversible. So when it is reversible, entropy generation will be 0, and it is adiabatic. So adiabatic means dq is equals to 0. So both the things will be 0 and ds will be 0. That is the only possibility. So only in this case entropy is not going to increase. Okay, rest all the cases entropy is going to increase. So I have 4 in every option, I think. Okay, now 1 is not here, so this is also not correct. C is the correct answer. Okay, C is the correct answer. 1, 2, 3 and 5 is the correct answer. Confused in 5. A liquid changes to gas. So basically you will be giving some heat, right? If you are giving some heat, so dq by T. When you have water, for example, you have water and you want to convert into gas, for example, vapor you want to convert. So you will be giving some heat. Now this heat, either if it is at saturated temperature, then only phase will change. It's okay. If it is not at saturation temperature, then temperature will change. But whatever is happening, some heat transfer is involved. And if heat transfer is involved, it is going to change the entropy, because dq is there. Okay. So maybe it is changing the temperature. Temperature will change. So it is sensible heat, or only phase change will happen. So phase change will happen. But whatever is happening, you are giving some heat, right? Okay. So that is why if heat transfer is involved, entropy is going to change. Okay. I hope it is clear. If it is only latent heat, so you can say by T of saturation. If only phase transfer is happening, phase change is happening. If phase change is not happening, then you can say MC ln T2 by T1. This is sensible heat. Okay. Let's move on to question number 54. Which of the following is incorrect for Rankine vapor power cycle? Rankine, read the options. 45 seconds you have. Read the options and tell me what is the right answer. Rankine cycle. Question number 54, which one is the correct option? For 54 question, now this is constant pressure, this is constant pressure, this and this is isentropic. They are saying incorrect, incorrect. Now we have 54C. Yes, that is correct. 54C is correct, Chaudhary. Umair, yes, 54C is correct. Please write. Umair, I don't know if you are answering for this question or the last question, but yes, if you are answering for this, 54 is correct. Please write the question number. My task gets easier. Okay. So A option is, it says it has 2 reversible adiabatic and 2 reversible isobaric process. Yes, I have shown you in the diagram. Its efficiency is, so efficiency of Rankine cycle, I can write 1 minus mean temperature of heat rejection by mean temperature of heat addition. So that is also true. So B is also true. C is constant pressure heat rejection takes place in turbine. No. Constant pressure heat rejection takes place in condenser. This is Q rejection. And it happens in condenser. Not in turbine. In turbine, isentropic expansion takes place. Okay. The efficiency of a Rankine cycle can be increased by increasing the degree of superheat at constant pressure. That is also true. Okay. So if you increase this temperature, this will increase and efficiency will increase. And heat addition takes place in the boiler at constant pressure. Yes, this is my Q heat addition and this is happening in boiler at constant pressure. So this is also true. Only option that is incorrect is C. So C is the right answer. Okay. Why there is 5 options, sir? Look, it's okay if there are five options. Okay. In some PSUs, sometimes they ask 5 questions as well, not usually in HPCL. But in some PSUs, because these questions have come from PSUs only. Okay. Sometimes they ask. It's not a very, shocking thing. Okay. Now, 55th question. So, I think now 6 questions are left, right? We will go to 60, right? So, timer is started. The efficiency of a superheated Rankine cycle is higher than the simple Rankine cycle. Superheated cycle efficiency of a Rankine cycle, I can write 1 minus mean temperature of heat rejection upon mean temperature of heat addition. B is the correct answer. 55B is the correct answer. Yes. Sir, आप thermal पढ़ाते हो? Yes, I teach thermal. No, yesterday only we had a class on YouTube. Okay, and not yesterday, day before yesterday. Okay, so efficiency of a super. Do I need to draw a diagram for you? Okay, let's see. I hope you all know what is the Rankine cycle. I just told you. Okay, so let me draw it here itself. Okay, no, leave it. Let me draw here. So a simple Rankine cycle will look like this. This is a TS diagram. A simple Rankine cycle will look like this. Okay. Now if I do superheating, where will I do superheating? I will do it in boiler. Okay. So this is 1, 2, 3, 4. Okay. Now I already told you what are the processes. 2 to 3 is boiler. 2 to 3 is constant pressure heat addition in boiler. Now what will I do? I keep reheating. I keep giving heat in the boiler. So that is superheat. Now if I keep giving heat in the boiler, so what will happen? This temperature is going to further increase and then expansion will start. This is going to happen. Now they are saying the enthalpy of main steam is lower for superheated cycle. No, because the temperature is higher in a superheated cycle. Now when I am superheating, my temperature is increasing. My temperature is going to increase. My enthalpy is also going to increase because enthalpy is a function of temperature. Yes, CPT, right? So this is wrong. Mean temperature of heat addition. So now because my temperature in the boiler is increased, so the mean temperature, what is mean temperature? Mean temperature will be the final temperature in boiler plus initial temperature by 2. So here we have T3 plus T2 by 2. Now because my T3 is increased in superheating, so my mean temperature is also going to increase. And if mean temperature is going to increase, this is going to increase. Okay, so yes, this is true. This is true. Till now we know that B is true. Okay, then the temperature of steam in condenser is higher. No, I don't know this because I am only superheating in boiler. Then it goes in turbine. Now turbine is only going to expand till the condenser temperature. So it is not going to affect the condenser temperature anyway. Okay, so this is also incorrect. And the quality of steam in condenser is low. Is this true? You see this diagram and tell me, earlier I have moved this side. Because of superheating, I have moved this side. So this side quality increases, not decreases. Now they are saying it is low. No, it is not true. Okay. So because of superheating, quality increases, not decreases. Okay. So this is also not true. I hope it is clear. Because scholarships tests are made like that, no? सही बोलो तो आपको पहली बार देखा. It's okay. There is always a first time, Podina. It's fine. Okay. But you can check my lectures on the YouTube as well as on app. Okay. And there are some recorded lectures as well. Okay. It's fine. Nothing to worry about. Things happen for the first time. Okay. Now let's move on to question. So B is correct. B is correct. We all know B is correct, right? Let's move on. 56 question and the timer is started. The function of condenser in a thermal power plant is, what is the, now where do we install a condenser after turbine? Okay, we have a boiler, then we have a turbine, and then we have a condenser here. Okay, actually condenser is very close to turbine, and then we have a pump, and then it goes back to the boiler. This is the flow chart. This is turbine. Okay, 56D, that is correct. 56D is correct. So condenser का function क्या होता है? What is the function of condenser? So first of all, whatever steam is coming in, from the turbine, it stores it. So it acts as the reservoir from the steam that is coming from the turbine. Okay. Then also it condenses that steam into water so that you can again pump it to the boiler. Okay, that is the second function. And it also creates vacuum. Why does it create vacuum? It actually maintains a little less temperature than atmosphere. Why? So that in the turbine you can expand it to the lowest minimum pressure and maximum work output. You see, this is your P, let's say 3, right? Whatever, I mean, yeah, 3. Okay. So you try to reduce your P4 to a minimum value, and if you are reducing the P4, then the expansion is more. Okay. The difference between the pressures is more and the expansion is more. So work output from the turbine is more. That is why you try to maintain a little lower pressure in the condenser and usually lower than the surrounding, so that in the turbine you can expand it up to surrounding temperature. Okay, so it also creates little vacuum in the system. So all of the above, okay, very nice. And 57th question, timer is on. Equivalent evaporation is defined as, equivalent evaporation. Could be Chaudhary. Okay, yeah, I think so. Yeah, that is true actually to some extent, but do not take it for granted. Okay, please try to evaluate all the options and see if really all of the above is true or not. Okay, equivalent evaporation, what is true? The amount of water evaporated from an end 100 degrees Celsius dry saturated steam. Okay, so I don't know if you know this definition. Equivalent evaporation is basically the amount of water in the boiler that is evaporated to the saturation temperature, completely converted into saturation, dry saturation at 100 degrees Celsius and atmospheric pressure. That is the equivalent evaporation. Okay, so the amount of water that is evaporated at 100 degrees Celsius and atmospheric pressure into dry saturated steam, that is equivalent evaporation. And it is also, in another terms, it is called as from and at 100 degrees Celsius. Okay, this is a way to say it. from and at 100 degrees Celsius. Okay. So if you didn't know this definition, now you know. Okay. Now we are left with 3 more questions. Okay. Let's move 58 question with reheat Rankine cycle. With reheat Rankine cycle, I hope you all know reheating cycle. Okay. What is reheating cycle? Rankine reheating cycle. And here again, accuracy and precision both are important. Yaar, what type of question is this? Both are important, no? 58D again, yeah, Chaudhary was saying it was correct. Yes, Podina, 58 is correct. So, in reheating cycle, what you do is, look, in exam you do not know. In exam you do not have to draw the diagram. Okay, the diagram is in your mind. So you already know the diagram, only you have to mark the answer. Okay, but because to explain I need to draw this. Actually precision is important but not as important. Look, precision is important when in numerical type questions in GATE, because you need to get a very precise answer. Okay, even decimal places you need to get a very precise answer. Okay, so if you are good with accuracy, if you are close, you know what is happening, then accuracy is much more important in PSUs, because the options are given to you and the more closest answer, whatever you are getting, the closest answer you can mark. But precision is more important in GATE. Okay, and usually in numerical answer type questions. Okay, now just bear with me so that I can explain for the people who do not know the reheat cycle. Now in reheating, what you do, you first of all expand it and then again it goes to the boiler. Okay, so you expand it from 3 to 4, then you again send to the boiler and then again you reheat it. So 4 to 5 is heat addition and then you expand in the turbine. So yes, quality of exhaust is steam. It is steam. Okay, STEAM. Steam is improved. Okay, whenever you are reheating, you are going on the right side on the vapor curve. So this quality X increases. Okay, X increases, that means amount of water vapor reduces. Amount of water vapor increases, amount of liquid decreases. Okay, so X increases, so this is true. Net output of the cycle increases. Yes, why? Look, this is the work output. 3 to 4 is the work output in turbine, and 5 to 6, this is 6, is also a work output. So yes, your net work output increases in a reheating cycle. Okay, then Podina, I am not sure when it is starting. Aptitude start in paid. I am not sure. I know that I will be starting Thermodynamics in the Vision batch from 7th of October, I think. Okay. Then, so this is also correct. And specific steam consumption decreases. Yes, because if the work output is increasing, then the amount of steam that is required from the boiler per unit work output decreases. Now you need less steam for the same amount of work output. So specific steam consumption decreases. Also one more point, that heat transfer Q supplied also increases. This is not given in question, but it could be one of the options. Okay, so Q supplied also increases. Okay, so A, B, C both are correct and therefore all of the above is the correct answer. 59th question, back work ratio. Now you all should know this, I am not going to explain this. A, B, C, D, 59, A, B, C, D, which one is correct? Timer is not required in this, but A, B, C, D, 59, A, B, C, D, E also. D is correct, yes. 59D is correct, that is absolutely true. Okay, where are other people? 59D is the correct option. Do you all know this back work ratio? It is basically when turbine work is compared with compressor work. Okay, yes, D is correct. And let's go to the last question, and then Chandra Sir Chandrasekhar sir will join. What range? Gas turbine. I have added some questions from Rankine. Again, we have some other mock test. Yes. Work ratio is 1 minus back work ratio. What is going to happen is, again, we are coming with other mock test, BHEL as well as HPCL. So today my focus was on thermodynamics and some part of power plant. Okay. And again, what will next will be heat and mass transfer, okay, and I think fluid mechanics as well, taken by Chandrasekhar sir. Okay, but what I am going to tell you is that today my main focus was on thermodynamics, but again I think this mock test will be coming up because your HPCL and BHEL exam is in late October, I think the end of October, right, 31st of October or something, and HPCL is in November, I think first week, 4th or 5th of November, okay. So in the month of October, we are coming up with more and more mock tests and practice sessions. So my focus will be, because I can't focus on everything all together. So in some sessions, my focus will be on applied. In some, my focus will be on basic thermodynamics, okay? And sometimes it will be all together, okay? In the last sessions, I will take all together, okay? So yes, the last question, 60th question. And we all know this isooctane content. Now in SI engine fuel, what do we have? The fuel consists of isooctane and normal heptane. After this, Chandrasekhar sir will join, and I think HMT and fluid mechanics he is going to take. Okay? Really? Chaudhary, no, why? Auto ignition, you see, in SI engine we try to reduce auto ignition, because if auto ignition happens faster, then what will happen? A different flame front will produce in the end, and a detonation will happen. Okay, so our purpose is to retard the auto ignition till our main flame front reaches the end of the engine. Okay, yes, knocking, detonation, knocking. Our aim is to reduce the knocking, reduce detonation, and that is why we have to retard the auto ignition. And isooctane, which octane number is 100 and normal heptane is 0. So 100 octane number means it has excellent anti-knocking properties. Okay, so it is a mixture of, our fuel is a mixture of isooctane and normal heptane. Isooctane has the best anti-knocking properties. Okay, so that is why isooctane content reduces or retards the auto ignition. It does not accelerate. That is in fact, normal heptane has the worst anti-knocking properties. So if you increase the quantity of normal heptane, that is going to accelerate the auto ignition, okay, and does not affect, no, it affects, okay. So A is the right answer. So I hope you all had a good session on thermodynamics, okay, and very soon we will be coming up with other sessions on mock test, HPCL, BHEL, and all together, okay. So also you can join my Telegram channel for regular updates on my sessions, especially on app and YouTube. And for these mock tests, you just keep updated. You join the BEP YouTube channel and you keep updated what are the next schedules that are coming in, okay. So join the Telegram channel as well. And I am going to stop here this session. I hope you had a very good practice session, okay. Chaudhary, thank you very much. Okay, so let's stop here, and I think and very soon Chandrasekhar sir will join for the next part of this session, and that will be the last part of this session, okay. Okay, so thank you very much and for being with me. Bye bye.
Hello everyone, can you guys hear me? कैसे हैं सब लोग? What's up? This is Chandrasekhar welcoming you all to the India's largest, the best, and your favorite live learning platform, BYJU'S Exam Prep. How is your energy? From 12:30 you are here, right? Good afternoon, welcome. Putina Yadav, कैसे हैं आप? Kumar, welcome to the session. So I will be having 25 MCQs in total from fluid mechanics, heat transfer, and the industrial engineering. बचा है क्या? नहीं बचा एनर्जी नहीं बचा। तो कितने देर होगी आपको? 2 घंटे हुए हैं अभी तो, 2.5 घंटे तो एग्जाम ही चलता है। कोई नहीं, आई विल ट्राई टू रैप इट अप एट as early as possible. So please be there with me, and this is the last part of our mock test. And I hope you guys are understanding the concept. You guys are improving your fundamentals by this test. It will help you to do not commit the mistakes in your actual examination. That will improve your understanding. That will improve your speed. That will improve your accuracy. All right. So this is my quick introduction for those who are meeting me for the very first time. My name is Chandra, Mechanical Engineering graduate from IIT Delhi, having more than 10 years of teaching experience in GATE, IES, and PSU. And you can join me on the Telegram as well. That is Mechanical by Chandrasekhar. For all the updates, I will share the PDF of this session also in the Telegram group. Only my questions I will share the PDF for, and I will also available for your doubt clarification through my Telegram group. All right. So start kare. Ready? Before we proceed, there is an important announcement. That is on 4th of October, your favorite Joshit Sir will be taking a special session at 8 p.m. You can register for the session. That is free, completely free of cost. It will help you to improve your strategy for GATE 2020. Right? And all the important links are already there in the description box. Please go through the description box after the session and you will find all the important links. All right? चलिए स्टार्ट करते हैं. Do not open your book. Do not cheat. Be honest with yourself and try to give me the answer at the earliest. Correct and fast. These are the two things which are important. शुरू करें. Ready with your pen, notebook, calculator as well as your keypad. Let me see who will be the first and the one who will give the right answer. The questions are very simple. The questions are very simple. The first question, the normal stress is same on all the planes at any point in a fluid only when the fluid is. Yes, what should be the answer? Quickly. I am not going to tell you. Normal compressive stress is pressure. It is the pressure. I hope you know the difference between pressure and stress. That is very, very general interview question. What are the various differences between pressure and stress? So if we are talking about the normal stress, it is the pressure. The pressure is same on all the planes at any point in the fluid, only when this is the Pascal law. The question is from the Pascal law. Option D. Very good. Pudina Umar. आपका वाकई में नाम पुदीना यादव है? टमाटर सिंह? You are very healthy name you guys are having. When the fluid is at rest, when the fluid is in hydrostatic condition, the normal stress will be same or the static pressure will be same at in a particular plane in different direction. It is independent of direction. All right. Pressure is a scalar quantity. We can call it a zero order tensor, and stress is the second order tensor quantity. It requires magnitude, direction, and plane of action. But whereas the pressure only requires magnitude, it is the scalar quantity, or we can call it a zero order tensor. The next question. बहुत बढ़िया, बहुत सही. The next one, hydrostatic force. Formula based, direct question, all the way from the fluid mechanics, hydrostatic force. The hydrostatic force on one side of a submerged surface of unit area with centroid 3 meters below the free surface. What is centroid? The center of gravity where the weight of the body is supposed to be acting. That is called a centroid. It is at a depth of 3 meters below the free surface of the liquid. What will be the magnitude of hydrostatic force from one side? So hydrostatic force is given by rho into G into A into X bar. And X bar is the depth of centroid of the plane surface from the free surface of the liquid. So it will be gamma, rho into G, gamma into 1 into 3 gamma will be the answer. Option A. Umar, Tomato, well done. Good, good, good. Keep it up. There are others. I want everyone to respond. Whether you are giving the right answer or incorrect answer, that is not important. What is important is your involvement, your participation. That is highly important to get the clarity to understand, because when you will not commit mistake, then you will not improve yourself. So committing mistake is all fine. Not be afraid of committing mistake. Question number 3 is from fluid kinematics. A fluid flow is said to be irrotational. When do we call the flow to be irrotational? And the flow is both steady and uniform. Is this correct? Or shear stress varies linearly across the section? Or fluid obeys Newton's law of viscosity? Or fluid has zero vorticity? Sometimes there might be a situation where you feel that 2 or more options are looking correct, but the one which is most appropriate will be the right answer for the question. All 2 or more option will not be exactly correct, but you might have a doubt. But the one which you feel more correct or more better will be the right answer. Correct. So the fluid flow will be irrotational when zero vorticity. What is vorticity? Twice of angular velocity, or we can say curl of velocity vector, curl of v, cross product of del operator and velocity vector. If it is zero, then the flow is irrotational. For irrotational flow, vorticity must be zero. Right? Vorticity will be. Question number 4, very simple, and the question from very, very important equation, that is the Bernoulli. What is the answer for question number 4? Everyone, it is about the unit only. P by gamma plus V square by 2G plus Z is constant. It is applicable to ideal flow. Bernoulli equation is only applicable to the ideal flow. What is the unit of each and every term from here? People know that the unit is meter, but in terms of work, what is that? This is joule per Newton. Joule per Newton. Joule is equal to Newton meter. So the unit of each and every term is energy per unit weight of the fluid. Another expression can be written as P plus rho GZ plus rho V square by 2 is equal to constant. Here the unit of each and every term is Newton per meter square or joule per meter cube. That is energy per unit volume. Each and every term will have energy per unit volume as the unit. If we write P by rho plus GZ plus V square by 2 equal to constant, so it is energy per unit mass, joule per kg, or we can call it as energy per unit mass. So it is work per unit weight or energy per unit weight is the correct answer of 4th option. D is correct. Option D is correct. Question number 5th. Question number 5th on the screen. The power dissipated in a light loaded viscous fluid lubricated bearing at n RPM is 1 kilowatt. The power dissipated at 2 n RPM will be. So we need to develop a relation between power and RPM, isn't it? The question says develop the relation between power and RPM. So power is what? Power is equal to force into velocity. Tangential force into velocity, that will be the power. Force can be written as mu into A into V by H, Newton's law of viscosity. So power is proportional to square and velocity is proportional to n. We can say power will be proportional to n square. That will give you value. So P2 by P1 equal to N2 by N1 square. N2 is 2, say it will be 2 square. It will be 2 square. P2 will be equal to 4 kilowatt. It will be 4 kilowatt. It will be 4. तो कैसे आ रहा है? It will be 4. Option B. Isn't it option B? B is the answer. Power is proportional to n square. Right? Here, very simple question, definition of equivalent pipe. It is from the compound pipe system. What is the answer for question number 6? No problem, Umar. चलिए बताइए everyone quickly, your time is running very fast. आपको भी घर जाना है, मुझे भी घर जाना है. Quickly, let us finish 25 question as early as possible. The pipe system is said to be equivalent to another when the following quantities are same. A pipe is said to be equivalent to a compound pipe system when the head loss and the discharge remains same. Head loss and the discharge. Yes, Pudina, Deepak, welcome. How are you? I hope your preparation is going smooth. Question number 7 from the boundary layer theory. Those who are having any doubt in understanding any of the concept, you can raise your doubt through the comment section. The thickness of laminar boundary layer on a thin plate is 2 cm at x is equal to L by 2. The thickness at x is equal to L will be. It will be more than 2. It will definitely be more than 2. Isn't it? As the distance increases, delta also increases. It will be more. It cannot be option A. C. Sorry, it cannot be option C. Preparation is going on in a turbulent way. Turbulent flow does not separate. It remains attached. So it is better. Your preparation, you are attached to your preparation. That is fine. That is good actually. So delta is directly proportional to root x if you know for laminar boundary layer. So delta 2 by delta 1 is equal to under root of x2 by x1. What is x2? That is L. L upon L by 2 under root. Delta 2 is equal to delta 1 is 2 centimeter multiplied by root 2. That will be the answer. 2 root 2. What is 2 root 2? 2.828. D is the answer. Option D. D is the correct answer. Question number 7. Right? Question number 8. From model analysis. Good. You guys are applying the concept of fluid mechanics in your day-to-day life. Engineers are so good in cracking the jokes that they use the engineering concept in their jokes. Question number 8. A 1:10 reduced scale model of a water turbine runs at the same speed as that of prototype runs. For prototype, let us say, what is the first step to write all the given parameters? Then you will be able to develop the strategy to solve. Prototype is, let us say, P, and M is for model. I am using these suffix, prototype and model. So 1:10, it means if the diameter of prototype is 10 unit, then the diameter of model is 1 unit, and the RPM is same. NP is equal to NM is equal to N, same speed. The ratio prototype to model turbine discharge should be. We need to find out the ratio of QP by. That is the question. How to find out QP by QM? So we can say Q is directly proportional to D square into velocity, and velocity is directly proportional to U is directly proportional into N. Q is proportional to D square into D into N. N is same. Remove this N. N is constant. So Q will be proportional to D. This is the expression. Q will be proportional to D cube. So QP by QM is equal to dP by dm to the power 3. What is the answer? What will be the answer? Question number 8. Are you getting D? 10 cube. Option D. D is the answer. The next one, question number 9 on your screen, from the rheology, from the concept of Newtonian and non-Newtonian fluid. If you relate with A into d by dy to the power n plus b, then A is equal to 0.08, n is less than 1, and b is equal to 0. What type of fluid? N is less than 1, n is less than 1, b is equal to 0. What type of fluid it is? It is pseudoplastic. Option B, Deepak. Well done. Good, good, good. Dilatant when n is greater than 1 and b is equal to 0, right? Bingham plastic when n is equal to 1 but b is non-zero. Thixotropic when n is less than 1 and b is non-zero. What is Newtonian? Newtonian when n is equal to 1 and b is equal to 0. What about rheopactic? When n is greater than 1 and b is... This is how you can compare and find out. B is the right answer. Yes, very good. You should not get confused. This is Newtonian. This is dilatant. This is pseudoplastic. And then 3 curves when tau is not 0. This is Bingham. This is rheopactic. This is thixotropic. This is the curve between du by dy and tau. These are the type of fluid based on the viscosity, Newton's law of viscosity. The next question, question number 10. Question number 10 on your screen. Assuming that the kinematic viscosity, they may not have used the word kinematic. The unit will decide whether it is dynamic or kinematic viscosity. The kinematic viscosity of water is 1 centistog. Kinematic viscosity, that is mu by rho, that is 1 centistog. That is 10 to the power minus 2 stog. That is 10 to the power minus 4 meter square per second. At room temperature, then the maximum permissible pipe diameter for maintaining laminar flow. For laminar flow, Reynolds number should always be less than 2000 for laminar. What should be the diameter? When the average velocity is 1 meter per second, so critical value is, what is the maximum Reynolds number? Re maximum for laminar is 2000. That is V average into D by kinematic viscosity. So D is equal to 2000 into kinematic viscosity, that is 10 to the power minus 6 on V average. 2 into 10 to the power minus 3 meter, or we can say 2 mm will be the answer. Option D. D is the correct answer. Right? Option D is the answer. For maintaining the laminar flow, that is the condition here. For maintaining the laminar flow. If you want to maintain the laminar flow, then the Reynolds number cannot go beyond 2000. 2000 is the upper limit for the laminar flow. 2000 is the upper limit for the laminar flow. Question number 11. Again from the Reynolds number and boundary layer theory. This is beautiful. Who will tell me the answer for question number 11? There are 25 questions and we are already halfway. So in next 20 to 30 minutes, I will complete my part and then HPCL mock test will be over. Please be there for the next 15-20 minutes more. Definitely it will help you to get better marks in your actual HPCL exam. If the Reynolds number for the flow past a smooth flat plate is 10 to the power 6. Flow past a smooth plate, what does that mean? Reynolds number at x is equal to L, trailing edge. At the trailing edge, Reynolds number is rho u infinity L by mu is equal to 10 to the power 6. What proportion of its length is likely to be? It is not converted, it is covered. What proportion of its length is likely to be covered by laminar boundary layer? Laminar boundary layer. This is how the boundary layer is. The initial part is laminar, then there is a transition, then the turbulent boundary. So how much portion is covered by laminar. So for laminar boundary layer, Reynolds number, it is external flow. Reynolds number should be less than 5 into 10 to the power 5. So the critical value of Reynolds number is 5 into 10 to the power 5. That is equal to rho u infinity x critical upon mu. From here we can find out this value. What is the rho u infinity by mu? 10 to the power 6 upon L. If we put the value here, we can say 5 into 10 to the power 5 is equal to 10 to the power 6 upon L into XCR. Can you find out the critical value of X? Can you find out the critical value of X? What is XCR? Five into 10 to the power minus 1 L. That is 0.5 L. That is L by 2, isn't it? The initial half length of the pipe plate is covered by laminar boundary. Option A. The first half will be laminar and the remaining half will be turbulent. Question number 12. Question number 12. From the buoyancy and flotation. Question is from buoyancy. A metal ball which is weighing 9 kilonewton in. So the actual weight is equal to rho of the ball into volume of the ball into G is equal to 9 kilo. But it is weighing 7.5 kilonewton in a fluid of a specific gravity 0.75. Why it is weighing 7.5? Because the weight is acting in downward direction and there is a buoyant force. So net weight is equal to W minus FB. That is equal to 7.5 kilo. From here, you can say actual weight is used to be 9 kilonewton. So the buoyant force by the fluid is equal to density of the fluid into the volume of the body which is inside the fluid, or total volume of the body, because the body is completely submerged, is equal to 9 minus 7.5. Isn't it? That is 1.5. If we divide these two, then density of the body upon density of the fluid is equal to 9 upon 1.5, that is 6. Isn't it? Now the question is, what will be the specific gravity of the ball material? We need to find out the specific gravity of the ball material. Need to find out the specific gravity of the ball material. That is density of the ball upon density of water. If we divide this by density of water, if we divide this density of water, so this will be 0.75. This we need to calculate, that is specific gravity of the ball is equal to 6 into, that will give you the 4.5 will be done. Buoyant force will be equal to 1.5 kilonewton and the specific gravity of the ball is 4.5. Whether the body will sink or not will be decided by the weight of the body and the buoyant force on the body. Deepak, it is not the specific gravity which will decide. It is decided by the weight and the relative magnitude of weight and buoyant force. The weight of the body is more than the buoyant force exerted, then the body will sink to the bottom. Question number 12. Is this clear to everyone? Please give me thumbs up. Please make some noise. Question number 13. This is the last question for FM. Then we will have some questions from the heat transfer and then some questions from the industrial. If phi, that is velocity potential function. If phi is given by xy meter square, the unit of phi is meter square per second. So we can say minus of del phi by del x is equal to u and minus of del phi by del y is equal to. The unit is meter square per second. The resultant velocity. What is u? Differentiate phi with respect to x. That is y. U is equal to minus y. What is V? V is equal to minus x. At point 1 comma 1, that is minus 1, that is also minus 1. So the magnitude of velocity is under root of square plus V. That is minus 1 square plus minus 1 square. That is 1 plus 1 root 2. Root 2 will be the answer. Option A. 39. Option A will be the answer. Alright. Now let us move to the heat transfer questions from the heat transfer. Shall we proceed? There are around 7 questions from the heat transfer and there will be 5 more questions from the industrial engineering. This is theoretical question, memory based question. What is the answer to question number 14? The efficiency of the fin. The fin efficiency, that is equal to Q actual upon Q maximum. That is efficiency of the fin with insulated tip. Option B, 1 upon ml when L is infinite. B is the right answer. What is the effectiveness of the fin? Q fin upon Q bare without fin. That would have been Km by H into 10 hyperbolic ml. Effectiveness would have been Km by H into 10 hyperbolic ml. 13. Option D is the right answer. For boiler heat capacity ratio, T minimum by C maximum. डेरिवेशन लेंथी है डेरिवेशन जरूरी है पर अंडरस्टैंडिंग के लिए. C minimum, boiler means evaporator, we can also call it as evaporator. Boiler or evaporator are same. The cold fluid undergoing a phase change. When the cold fluid is undergoing a phase change, there is a phase change. So delta Tc is equal to 0. There will not be any temperature change, or we can say Cc is infinite. Cc is infinite, then it will be Ch by Cc. When Cc is infinite, heat capacity rate will be 0. It will be 0. Question number 15, option A. Option A is the answer. For boiler, the ratio of heat capacity rate will be 0. And in that case, when C is equal to 0 or when any of the fluid is undergoing a phase change, the relative direction of the fluid flow becomes insignificant as far as the thermal performance is concerned. Question number 16, again memory based question. Whether you remember the formula or not, the Nusselt number is related to Reynolds number in laminar and turbulent flow respectively. For laminar flow, Nusselt number is directly proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. For turbulent, Nusselt number is proportional to Reynolds number to the power 4 by 5 into Prandtl number to the power 1 by 3. It is 4 by 5 and 1 by 2. For laminar, it is 1 by 2, 0.5. And for turbulent, the power of Reynolds number will be 5. Is the answer? Is the correct answer? The question is from the shape factor. What is the answer for this question? A long solid cylinder, surface 1 of diameter d1 is enclosed by another long concentric cylinder. I am drawing the cross section. This is 1. It is insulated from inside. An outer cylinder, that is 2, insulated from outside. And because they are very long, they can be treated as enclosure. If d2 is equal to twice of d1, if d2 is twice of d1, d2 is to d1, the percentage radiation from surface 2 to itself, that is F22 will be how much? That is the question. We can say F11 plus F122 is equal to 1. What is the self shape factor of the convex surface? 0. For convex surface, it is 0. And we can say A1 F122 is equal to A2 F221. F122 is equal to, sorry, F221. So we can say F221, that is the reciprocity theorem. F221 will be equal to A1 by A2 into F122, and F122 is 1. And one more equation we can write, enclosure theorem, F221 plus F22. F221 minus F221, that is 1 minus A1 by A2. A1 is pi D1L, A2 is pi, it will be 1 minus D by D2. What is D1 by D2? D1 by D2 is 1 by 2, so 1 minus by 2 will be the answer. 0.5 percentage, it will be 50. C is the answer. Question number 17, option C. Reciprocity theorem, enclosure theorem, if you apply, then you will get. Question number 18. Question number 18, next one. A steel plate is exposed to solar heat flux of 800 watt per meter square on one side. There is a solar heat flux on one side, 800 watt per meter square. The plate is exposed to air at 30 degrees Celsius on both the sides. Here the flue temperature, air temperature is 30 degrees Celsius. Here also T infinity. The convective heat transfer coefficient is 10 watt per meter square Kelvin on back side. Here H is 10. H is equal to 10. Here H is equal to 15. And 15 on the front. The equilibrium temperature of the plate is. Temperature of the plate will be. So we can say from the energy equation, we can say whatever the heat entering will be equal to heat leaving, and heat is leaving by convection from the front and convection from the back. What is Q? That is 800 per unit area. It will be 800 is equal to 15 into T minus 30 plus 10 into minus 30. 800 is equal to 15 plus 10, 25 into Tp minus 30 will get you the answer. What is the temperature of the plate? What will be the temperature of the plate? Here written per unit area because area will be same. Front and back area will be same. What is the answer? 18. Option B, 62 degrees Celsius will be the answer. Yes, correct, Umar. Well done. What about others? This is from heat generation. Again, formula based, but whether you remember the formula or not, that is still the question. Second last question from transfer. The center to surface temperature difference in a heat generating cylindrical rod of diameter 8 cm is 30 degrees Celsius. Under similar condition, the center to surface temperature difference in case of a sphere. So for a cylinder, T maximum, that is the center temperature, is equal to Ts plus Q dot R square by 4K. And for a sphere, we can say delta T for cylinder, T maximum minus Ts is delta B, that is Q dot R square by. And for a sphere, T maximum is equal to Ts plus Q dot R square by 6K. These are the standard formula when there is a heat generation. For this delta T, for a sphere is equal to Q dot R square by 6. So the question is, what is in case of sphere, delta T for sphere upon delta T for cylinder will be how much? That is 4 by 6, 2 by 3. You can find out delta T for sphere. Delta T for cylinder is 30. 30 into 2 by 3. How much is that? What is the answer for question number 19? T, 20 degrees Celsius. Last question from the The last one from the heat transfer, then 5 questions from the industrial engineering. A vertical surface 5 meter high, that is from natural convection. The question is from the natural convection. Vertical surface 5 meter high is at 80 degrees Celsius. Yes. And is surrounded by air at 20 degrees Celsius. The value of average heat transfer coefficient at the location where Grashof number is 10 to the power 8, 48. The value of H is 48.3 when Grashof number is 10 to the power 8. The average heat transfer coefficient at a location where the Grashof number is 10 to the power 4 is. You read the question, you need to develop a relation between H and Grashof number. And as the Grashof number is less than 10 to the power 9, so the motion is laminar. It is the laminar boundary layer. And for laminar boundary layer, for natural convection, Nusselt number is directly proportional to Reynolds number into Grashof number into Prandtl number to the power. Do you remember? To the power. Isn't it? For laminar. For turbulent, Nusselt number is proportional to Grashof number into Prandtl number to the power 1 by 3 for turbulent. It would have been for turbulent, it would have been 1 by 3. For laminar, it is 1 by 4. And Nusselt number is directly proportional to H. So H is proportional to what we can say from here. What we can say, H is proportional to Grashof number to the power 1 by 4. You are able to develop this relationship, then you will get the answer. Grashof number to the power 1 by 4. What is the answer? H2 by H1 is equal to GR2 by GR1 to the power 1 by 4. What is the answer for question number 20? Are you getting option C? C is the answer. Now 5 more questions from the industrial engineering. The next question, the primal of a LP problem is maximization of objective function with 6 variable and 2 constraints. Which of the following correspond to the dual of the problem stated? How to convert primal into dual, and why do we require that? To reduce the number of variables. If primal is maximization problem, dual is minimization. If primal is the number of variables in primal is equal to the number of constraints in dual. And the number of constraints in primal will be equal to number of variables in dual. This is how primal can be converted to reduce the number of variables. If the primal is having 6 variable and 2 constraints, the dual will be having 2 variables and 6 constraints. 1 is correct, 2 is incorrect. If the primal is maximization problem, then the dual will be minimization of objective function. 1 and 4 are correct. 1 and 4. Option B. Question number 22. Question number 22. When solving the problem by big M method, if the objective function rho shows optimality but one or more artificial variables are still in the basis, what type of solution? When the artificial variable is still there in the optimum table, then it means it is having infeasible solution. No common region. It is infeasible solution. No, it is not degenerate, it is infeasible. Unbounded solution is, when do we have unbounded solution? When all the pivot elements, all pivot column elements are negative. Then unbounded solution. When do we have degenerate solution? When the solution is done degeneration. If there is a tie in selecting minimum ratio, then there is a degeneracy. And there is one more alternate solution. many solution when non-basic variable has zero Z-row coefficient. When non-basic variable is having zero Z-row coefficient, then it is or infinite solution. These are the methods to find out whether the solution will be optimal, unbounded, degenerate, infeasible, or alternate. So D is the right answer for question number 22. Which one of the following is not the solution method for transportation problem? This is simple. Question number 23 is very simple. This is for assignment problem. And these are the starting solution for, these are the starting solution for transporting. A is the answer. Question number 24. Second last question for the day. For a transportation matrix which has 6 rows and 4 columns, not to be degenerate, number of allocated cell will be equal to number of independent constraints for no degeneracy. For no degeneracy, number of allocated cell, so it will be m plus n minus 1. Number of rows, number of columns minus 1, because there is one constraint which is dependent. We need to subtract that also. It will be 6 plus 4 minus 1. Number of allocated. He is the answer. And the last question from the queuing theory. On an average, there are 30 customers in a queue. So LQ, length of the queue is 30. If the arrival rate of customer into the system is 60 customers per hour, arrival rate lambda 16 per hour, and on an average 32 customers leave the system per hour. Mu, departure rate is 32 per hour. Then the average number of customers in the system is, so LS will be how much? The system. LS is equal to LQ plus, isn't it? Rho is equal to lambda by mu. Is 16 by 32. That is 1 by 2. That is 0.5.